with the help of this select operation, we can extract or we can fetch the particular row or a particular record or a tuple. Whatever the column that I wanted to retrieve, then only we have to use this projection operation. If I wanted to merge or if I wanted to perform the union operation between A and B, at that time we have to take a same number of attributes from both the relations. Hello everybody, a warm welcome to one and all. Welcome back to the session 2, and we are in the chapter 2, that is relational data model, relational constraints and relational algebra, and we are dealing with the unit 2 of a B.C.A's 4th semester subject called Database Management System. In short, it is DBMS. I'm Rohini TS, Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So before getting into our today's session, we'll see the recap of the previous session. So in our last session, we have discussed regarding relational data model, and also we have discussed regarding some of the concepts which is related to the relational data model, and also I have discussed regarding the relational constraints. So that is set of rules and regulation that needs to be obeyed by the relational data model. So that includes key constraint. When it comes to the key constraint, it's supposed to be with respect to the primary key. It should not be null and it must be unique in nature. Along with that, we have discussed regarding the domain constraint. That is what set of range of values that we are going to give for the particular attributes. For that, we have certain rules and regulation that needs to be followed in order to satisfy this domain constraints. And also, I have discussed regarding the referential integrity constraint. This is what we have discussed in our last session. In our today's session, we'll continue with this. Along with that, we will be learning regarding this relational algebra. That means, what do you mean by relational algebra? For what purpose we are going to have it? And what are the basic relational algebra operations we have? We'll see regarding that. And also, we'll see some of the additional relational algebraic operations. Let me get into the today's session, that is with respect to the relational algebra. So, before understanding what are the operations we have in a relational algebra, it is very much needed in order to understand what do you mean by relational algebra. So, when it comes to the algebra, there we are going to perform some of the operation, right? So, then what about this relational algebra? Already we know about the relation and we also know about the relational. That means every data will going to be considered in the terms of tables. So, we should not call that as a table, it is relation. And each row will be considered as a tuple or a record, and each column will be considered as an attribute or a property. So, now what do you mean by this relational algebra? You can see here, it is a procedural query language. Mainly we are going to use this in order to select or to put some query to the database of RDBMS, that is Relational Database Management System. So, in order to work with that, we are going to use this relational algebra as a procedural query language. And also, it consists of a set of operations that take one or more relations as an input. What is the input that I am giving here? That we are giving one or two or more than that as a relation. We are giving a relation as an input. After doing some of the operations or after doing some of the calculation, it will going to produce a new relation as the result. So that you have to understand one thing, relation will be the input. After the processing of that, even the output or a resultant will also be a relation here. That is, table will be the input and return value or a result will be also in the form of table. It's not table, it's relation. So now we'll see about the operations which we can done in the relational algebra. So here you can see that we have a basic relational algebra operation. So the fundamental operation in the relational algebra are, what are the fundamental operations that we have in the relational algebra? It includes select, for that we are going to use a sigma, and also we have a projection, that is pi, and also we have a union, it's a combination. We'll see what about this union and what do you mean by set difference here, and what is Cartesian product as well as rename. So if you just see these names, simply you can understand what are the operation it could be performed. So apart from this basic or fundamental relational operation, we also have some of the additional operations that include set, intersection and natural join as well as the assignment, and also we have a joins and we have an inner join, outer join, that you are going to learn in the coming session. So as of now you need to understand regarding all these fundamental relational algebraic function. We'll see about the first operation, that is select. So when I wanted to understand anything with respect to the algebra functions, or if you wanted to learn about the relational algebra operation, everything will be considered as a table, that is relation. How it will be then? It will be like this. It consists of rows as well as column. Rows are considered as a tuple and column will be considered as a attributes or properties, right? And also input will be relation, output will be relation. What if I wanted to select a particular tuple or a record? At that time we have to use an operation called select operation, so that with the help of this select operation we can extract or we can fetch the particular row or a particular record or a tuple, so that the select operation selects the tuples that satisfy a given predicate. So based on certain conditions it will going to select a row or a tuple. So for that reason we are going to have this select operations, and also we are going to use a sigma, letter sigma, in order to denote this selection operation. So you can see the syntax here. Here we have a sigma. Along with that, within parameter, as a parameter we have to give certain condition, that is what? Selection condition within the relation. I have to specify from which relation it has to take that value. So that is what you have to understand here. So here you can see that sigma is used to denote the select operator. Here we are going to use this sigma operator in order to specify we are performing the select operations and also selection condition. So that needs to be satisfied from the R called relation. From particular relation or a table, we are fetching the row or we are fetching the tuple. So for that reason, we are going to have this select operation. So let me consider an example here. So here I have a row operator, and also I am going to write department number is equal to 4 from the employee. So what it will going to give then? You just imagine here we have a employee table or employee relation, and it consists of employee ID, employee name will be there, as well as consider department number and its designation, right? So let me consider 1, 2, 3 and let me consider A, B, C. Here it will be 2, 4, 6 and department will be X, Y, Z. So you just imagine in this way. So now what I'm looking for, I wanted to select the row which is department number which is equal to 4. Then it will going to return this tuple or a record from the relation called employee. So in order to fetch a particular row or a tuple in the relation, we are going to use this select operation. So what if I wanted to select column? For that reason, we have this projection operation. So this projection operation will going to help us in order to select a particular column. So that is also based on certain condition. We'll see now the projection operation selects certain columns from the table, discards the other column. So whatever the column that I am fetching for or whatever the column that I wanted to retrieve, then only we have to use this projection operation. So it will allow us to take or to select certain column from the relation. So if I am not selecting any one of the column from that relation, then it won't select that column. Apart from that, whatever the column that we have selected, with the help of this projection operation, we're going to return the column. So you can see the syntax. For this projection, we are going to use a pi symbol and we have to give the list of attributes. Why? Because attributes are nothing but columns. So if I wanted to fetch certain columns from the relation, I have to take this list of attributes and from the relation R. So that you have to mention, or else you can also have the syntax in another way. That means here also I need to specify the pi symbol. Along with that, I can take column 1, column 2 up to column number n, and from the table name, that is relation name. So you just imagine I have an employee table here again, and it consists of employee ID and name will be there, as well as you imagine it consists of age. So now I just wanted to fetch employee ID as well as the name from a relation called EMP. How I am supposed to write that? We'll see. You can take the pi symbol, and within that I need to mention employee ID, then put comma. After that I wanted to retrieve the name from the relation, which is the name of a table here, that is EMP, right? So this will going to allow me in order to select or to retrieve this employee ID and name column from the relation called EMP. Result. So here pi is the symbol used to represent the project or projection operation, and here we have a list of attributes or a list of columns we are taking from the relation R. So this is mainly to retrieve the column. Remember, select operation is used to retrieve the rows or tuples, and this projection operation is used to select the columns or attributes. This is regarding two of the operation. We'll see the further thing, that is union operation. So if I say union, you have learned about the union since your school days, right? So union in the sense what? Whatever could be the values or whatever could be the number of rows in the relation A and relation B, that is table A and table B. So we are going to combine everything. So at last, as a resultant, it will give all the tuples from the relation A as well as from the relation B. So for that reason, we are going to have this union operation, so that it is used to fetch the data from two relations. So we are to consider two relations. For that reason also we have told you already, like when we are working with this relational algebra, it will going to take two or more input or two or more relation as an input, and it will produce this resultant even as a relation. So mainly we are going to use this operation to fetch the data from two relations or a table, and the tables can also be a temporary relation. Let me take one example here. So here you can see that we have a relation A and relation B. So if I wanted to see it as a relation, it must comprise of rows as well as the column. Let me consider it has 3 rows and it has 2 rows or a tuple. But here you have to understand one thing with respect to the constraint. That means if I wanted to merge or if I wanted to perform the union operation between A and B, at that time we have to take a same number of attributes from both the relation. Then only it will be possible to do the union operation. So for that reason, it has to comprise of 1 and 2. Here also we have 2 attributes or a column, so that I can perform the union operation between A as well as B relation. So whatever may be the content in the A, that will going to be fetched as well as from the B. At last we are going to get the resultant, that is also combination of A as well as B. So this is regarding union operation, and the syntax will be like this: A union B. So now we'll see about the set difference. So here, for what reason we are going to have the set difference operation? We'll see now. This operation is used to find the present in one relation and not present in second relation. So if I wanted to say it like A minus B, then I am fetching the content whatever is there in A but what is not in the B. So in order to find the difference between two relations, we are going to have this set difference operation of a relational. So syntax will be like this. It will be A minus B. If it is A minus B, then whatever the content or whatever the tuples in the A will be present as it is, but it will result in or it will going to give us which is not in B. So you can see here the result of A minus B is a relation which includes all the tuples that are in A. So we are going to take all the tuples or records from the A relation, but not in B. So we'll take all the tuples from A, but that should not be in B. So that kind of value or that kind of tuples will be selected when we are performing this relational difference. And also the attribute name of A has to match with the attribute name of B. So if I wanted to do the set difference, then whatever the name of attributes we have in A, that should match with the attributes of B. Then only we can find the difference between A as well as B. Okay, this is regarding difference. We'll see the next operation, that is Cartesian product here. For that, we are going to use a symbol called X. So Cartesian product in the sense multiplication, right? So if it is a Cartesian product, so consider I have A relation and B relation. Let me consider this as A and this as B relation. So imagine it has two attributes and it is also has two attributes, and number of tuples will going to be vary from one relation to another relation. So when we are performing this Cartesian operation between A and B, at the time it will select all the attributes from A and it will combine with all the attributes of B. So then by doing this Cartesian product operation, this will going to gives us new relation. So we can fetch the data from A as well as B and it will be combined together and we can get the data from a combined relational data here. So that this is used to combine the data from two different relations, so into one. So we are combining the data from A as well as B and that will going to help us to form a new relation so that we can fetch the data from the combined relation. So what is the syntax we can use for this? That is A cross B. And also you just imagine we have a and B, that is two relations we have here. So that if I am doing this Cartesian product operation, then the resultant will be all the attributes of A which is followed by each attribute of B. That is what Cartesian product of this operation. And also each record of A will pace with every record of B. So this is how we are going to do the Cartesian product operation. We'll see the next one, rename operation. For that we are going to use a row operator here. Okay, in order to represent the rename, we have a row operator. So as the name indicates, what do you mean by rename here? If you wanted to change the name of a relation from existing name to new name, then we are going to use this rename operator or a rename operations. And also this operation is used to rename the output relation for any query operations which returns result like select, project, etc. or to simply rename a relation. So you just imagine you are performing some of the operation, you are selecting or you are updating, or some of the projection operation you are doing. After selecting of certain tuples or after selecting of certain column, then resultant will be one more relation or resultant will be one more table. So for that I wanted to rename it. I wanted to give new name for the existing table. So for that reason we are going to have this rename operations. And how it will be done? So you can see that we have a row symbol and also relational new, relational old. Consider EMP employee. So from which name to which name I have converted? Initially it was employee. Now we have renamed that relation as a EMP. So for that reason we are going to have this rename operation, and this rename operation is used to rename the output relation and it will be denoted by a symbol called row. So first we have to give the relational new name as well as which needs to be followed by old relation or a table name. So for that reason we are going to have this rename operation. So these are the fundamental operations of a relational algebra. So for what reason we are going to have this additional relational operations? That means when the request is given to the DBMS, at the time that request can't be processed by the basic relational operation. At the time we are go with this additional relational operation. It will going to improve the efficiency of a relational operation, and in order to define the additional operation, we are going to request whatever given as a query from the customer or from the end user. will be reached to the RDBMS, and mainly it will going to enhance the expressive power of the relational algebra. And here you can see that we have additional relation operations that includes aggregate functions as well as grouping, and also we have a recursive closure operations, and also we have outer join as well as outer union operations. So these are the additional relational operation mainly in order to improve or to enhance the expressive power of the relational algebra. We'll see about the aggregate functions here. So when it comes to the aggregate function, we are going to use it on a particular column. So based on that, we are going to do these operations. So that includes sum, average, maximum as well as minimum, and also it includes count, right? So if you consider this count, that will going to count the number of tuples or a values in a particular relation. So and if it is a max, then it will going to select the maximum from that particular column. And you just imagine here we have a employee table, and that comprises of employee ID, name, their salary, right? So these are the attributes, and here also we have a tuples or a records value will be there. And if I wanted to find which is the highest value or which is the minimal value from this salary column, so for that reason we are going to have this aggregate function. So that we are going to discuss about all these in the coming sessions. So as of now, you need to understand what is this F max of salary of employee. So here employee is the name of a relation, from which relation we are taking that value employee, right? And we are finding the maximum salary of an employee, those who are taking highest salary among all these values that we are fetching, and also for the minimum salary and sum of salary. So if it is of 3 tuples, every values or every value of that salary column will be added together, then that will give you the total salary or a sum salary. And also we can have the count, that means it will going to count the number of tuples or a number of values which is present for a particular type of attribute. So these are regarding aggregate functions. And also we have a recursive closure operation. This is another additional operation. For what reason we have to have this? A common type of operation that usually cannot define in the relational algebra. So the operation which cannot be defined in the relational algebra will be considered as a recursive closure. So this operation is used exclusively in the recursive relationship. So we have 3 kinds of relationship: binary, ternary and recursive. So when you wanted to do the operation with the recursive relationship, then we have to use this recursive closure operations. So for that reason we are going to have this, and it will going to be described by a foreign key that relates each tuple in a table similar to another tuple in the related table. Mainly to have a referential integrity, we are going to use this recursive closure operation. This is also enhancing the performance of a relational algebra by improving the recursive closure relationship. So these are the additional relational operations that we have in a relational algebra. I hope you all understood my today's session. In my coming session, we'll see about the last part of your unit 2, that is normalization. What do you mean by normalization? For what reason we must learn this normalization, and what are the types of normalization we have, that I am going to discuss in my coming session. Keep learning, keep on growing. Thank you.